In this video, I'll calculate how much power is produced by Hussein, I don't know how to say his name. He is a world record holder in the clean and jerk, so he's going to pick this mass up and hold it over his head. It's 263.5 kilograms, so we'll see how much power he can produce while doing that. First thing you need to do is actually go to this YouTube video and watch it so you can see what he's doing. Then you'll know what I'm talking about in the solution. The first thing I've done here is I've drawn, well, this is supposed to be the barbell. So the barbell starts down here, 263.5 kilograms, and it goes up. So I know the mass, I'm looking for power, and I'm not given anything else. Now if you watch in the video, this, he just starts to pick it up at 35 seconds. So 35 seconds into the video, it's still sitting on the floor. At 45 seconds, it's up. So the time that it takes for him to lift it is 10 seconds. So that's something. It would also be nice if we knew that height. I don't know how tall he is, but he seems to be about person height. I'm also about person height. And if I finished like this, my hand would be this high above the floor, and this is a 2-meter long stick. So that means he must have lifted it about 2 meters. We will estimate that he lifted it 2 meters. So delta x, 2 meters. Power. So power is, well, it's work per time. We have time, so if we can figure out work, we'll be good. Work is force times distance times the cosine of the angle between them. Let's see. Force, I'm pretty sure he applied a force upward when he was lifting it. So the force is up. The distance, so it moved also up. So up and up, the angle between those two is 0 degrees. So cosine of theta, that's 1. So the distance, we know that's 2 meters. What's the force? In order to lift something up against gravity, you've got to provide the same force as gravity. Okay? Technically, to get it to start moving, you need to apply a little bit more to make it accelerate up. And then once you've got it going, you apply just the force of gravity. Once it's at the top and you want it to stop again, you apply a little bit less than the force of gravity so that it will stop moving. But overall, for most of the time through, it needs to be the force of gravity. So we can replace that F with mg. So m times g times that distance over time. So the power is 263.5 kilograms times 9.8 meters per second squared times that distance of 2 meters over a time of 10 seconds. 516 watts. Doesn't sound like all that much. I mean, a 100-watt light bulb, this would be like him lighting up 5 100-watt light bulbs. Let's think about it in terms of horsepower, because I'm in America and I know a horsepower is supposed to be about the amount of power that can be produced by a horse. So 1 horsepower is about 750 watts. So this is about 2/3 of a horsepower. So he is about 2/3 as powerful as a horse. So that seems like a reasonable answer.